Hello, everyone. This is Matt Bichelle on behalf of Aerospike and 451 Research. I'd like to welcome you and say thanks for attending today's webcast titled How NoSQL Trends and Consistency Are Fueling Enterprise Digital Transformation. I'd like to begin by introducing our presenters. Leading off today's discussion will be Jim Curtis, who's Senior Analyst, Data Platforms and Analytics at 451 Research. Jim has over 20 years experience in the IT and technology industry. He has experience covering BI reporting and analytics sector and currently covers Hadoop, NoSQL, and related analytic and operational database technologies. Also presenting today is Ananth Subramanya, Practice Head Digital Analytics for HCL Technologies. As the Head of Platform Solutions at HCL, Ananth guides enterprises in their digital journey. He has a background as both a solution architect coupled with decades in delivering transformation projects, as well as having served as a support engineer, development lead, test manager, product manager, pre-sales consultant, and a regional field sales director. Ananth has personally grown a 30-member team to over an $800 million practice. Before we get started, I'd like to take care of some housekeeping items. To ask a question, simply type it in the question box on your screen below, and we'll get as many questions in as we can. We'll also respond to all unanswered questions via email after the webcast concludes. This presentation and slides are available for download on the replay. And finally, please provide feedback at the end of the webinar. So with that, I'll turn it over to Jim. Jim, please take it away.
All right, thank you, Matt. Let me forward here. So some of you may or may not have heard of 451. Let me just give a quick overview of the company I work for. 451 Research is a research and advisory company. We produce a lot of content and research about sort of the IT market in general, which covers a lot of channels from mobile to analytics to databases to IoT and some of those things. We've been around since about 2000, so we're coming up on almost 20 years, and we have roughly about 350 employees in our company. Maybe half of those are roughly publishing analysts, such as myself, producing research and content on a regular basis. I want to point out, I'll let you read some of these other details, but we have a community of about 70,000 or more IT professionals that we reach out to on a regular basis. This might be either through briefings or surveys or extended conversations in which we have, and that helps us get a pulse and have a very accurate reading on the market. And I'll referring to some of this data points sort of later on in my discussion, but just kind of wanted to point that out to you. Okay, so we're going to be talking today a little about the NoSQL database space and how it sort of matured over the years. But I have a quote here that basically says that as you're starting, maybe a strategic enterprise, is that you want to avoid the assumption of always relying on sort of a relational database. So the relational database has been around for perhaps more than 40 years. That model it served well, but we are entering an era when other data models and other ways of sort of storing and pulling up data and querying that data and storing it might actually be a little better depending on the application situation. So let's talk a little about this. So the birth of NoSQL, it's a market that's been roughly coalesced just under 10 years. In 2009, it's kind of when it first emerged. Although some of the technologies and the ideas and concepts of having databases that were other than relational have actually been around for many years before. But it wasn't until sort of 2009 where it sort of kind of came together and this became kind of a market in and of itself. Initially, when NoSQL started, it was meant to be sort of not SQL and a clear demarcation. But that has actually sort of changed a little bit to where NoSQL really means now not only SQL, meaning that there's some overlap and even a complementary nature with relational databases in general. However, NoSQL does operate with a distinct and sort of different data model, as we're getting into, than relational. So there's just sort of some touch points as we sort of get into it. So as I mentioned before, the traditional database, the relational database, although it's been sort of a mainstay of businesses, is at times we've seen it get stretched beyond its ability to sort of perform what it needs to do, whether that is, being a concurrency or distribution or certain aspects of it, depending on the applications on that, it may or may not always be the best fit. And so from a NoSQL standpoint, some of the data models that are defined within this are roughly 4. And if there's a database that is one of these databases, it's considered sort of part of the NoSQL space. So I'll just sort of briefly go over these. So one of them is what's called a key value, which basically looks like a 2-columnar table. And key value models are really good at a couple things. The concept is that there is a value and then there's a key. And so the value might be a phone number and the key might be someone's name. And you can link the two to find that information. Key values are very good at sort of writing information and then returning results extremely quick. And so we see things like profiles and catalogs and session information, shopping carts and things like that are actually very, very good scenarios for key value stores. The other one is kind of a wide columnar. And so this is, again, it's very similar, but the data is actually sort of stored in, it looks like relational in some ways, but it's more stored in a column. And then there's segments or there's tables sort of inside those columns. And the one good thing about wide columns is that they often are sort of resilient and they scale very well. And they have oftentimes sort of high availability. And these types of data models work good for sort of product catalogs, logs, messaging, and even fraud detection, where you can sort of write and call up information very, very quickly. The other one is document. Document is, this model is, I guess, somewhat different, although it has some properties and similarities to sort of a key value store. And so one of the ideas of the document is that each of the files are sort of stored in these documents, and that looks like, sort of brackets. But you can add different types of information within these documents and then sort of call those documents up. The documents could be an XML file, it could be a JSON, for instance. And again, these work very well for things like chat sessions or ratings or comments and things like that. So the fourth item is, or the fourth data model is called a graph model. And this is sort of one of those things where one of them doesn't belong with the other. Graph is really a segment where the data that you put in the model is very relational, okay? Just things like social, friend of a friend of a friend, things like that. So, but graph is part of NoSQL because it doesn't necessarily conform to, say, relational, but it's more based on a relationships of that. So there is some characteristics there. So we'll sort of move on a little bit forward, but that just sort of gives you a sense of that. There are vendors that have sort of multiple data models, they'd call them, where they employ more than one of these models within their product. But at the base, these are the 4 that we consider part of that. And so what do we talk about when we think about NoSQL? Well, NoSQL really has some characteristics, I think, that I mentioned before. When relational wasn't necessarily working for enterprises, they were really after sort of these 5 things. They really wanted scalability. The idea that as my load and as the data comes in, I need to sort of scale out, okay? Traditionally, you would scale up, just adding more memory, more storage, and more compute. But the idea of sort of scaling out in a distributed nature allows you to handle significant load and data. And that's one of the things that NoSQL often provides in this scenario. The other one is cost. The idea is that NoSQL databases, many of them are also open source, but many of them also come with better cost licenses or scenarios than might be some of the traditional relational databases that in some ways might be overkill for a situation. And so sometimes, sort of speaking broadly here, is that NoSQL generally tends to be more cost favorable in some circumstances. So the other one is availability, and this is the idea that as you have perhaps high load, you don't necessarily want vulnerabilities to the system. You want it to be up all the time, particularly if you're perhaps serving web applications or things of that nature where disruption can actually be very disruptive to the end user, and you might, in fact, lose customers because of it. So the idea of nodes going down and be able to self-heal and be able to maintain its state is actually very important, and NoSQL generally has been very good at that. So the other one here is low latency, and that's the idea is that I want to query something and get a response back very, very quickly. And so in the relational world, you can do that, but it depends on the nature of that query and how many tables and such might be accessed, and if there's joins and other things that may occur. But NoSQL, because they have in some ways more simplified or more refined data models, they generally have very low latency, and you can sort of pull up the information you need very, very quickly. The fifth piece here is sometimes what we call elasticity, and this is the idea is that it sounds like scalability. This is more the idea of being amenable to sort of different data models. Okay, the idea is that I can accept different and certain types of data into my system, load that, and then sort of query and access that very quickly. Again, in a relational model, oftentimes the data has to be prepared and conform to a certain data model before it's sort of loaded into the system. So again, those are sort of general. There'll be vendors that have sort of different takes on those, but those are just generally some of the traits that we see in this market. Okay, so from a broader market perspective, what is going on with NoSQL? Well, actually, we actually see our forecasts we see a significant amount of growth going forward, and particularly in the NoSQL space. So you can see on this, actually, I see I've got a typo. It should be 2017 to 2022. But the idea is we basically see a 23, almost 24% CAGR over these years. What you don't see on the slide is that the NoSQL space itself is like 29%. So we actually have forecasted significant growth with these types of databases in the space. And some of that attribution can be the fact that we are entering a phase of what's called digital transformation, where people are digitizing their businesses generally. And NoSQL tends to be a really good component of those transformations. And so we think that's at least one component sort of driving this growth, as well as some of the capabilities that these databases bring. But regardless, the takeaway is that this is a growing and ramping up space, and we should expect it to continue for many years to come. All right, so beyond some of the 5 components I mentioned before, what are some trends or expansion areas we're seeing within NoSQL? I've listed here some of the ones. We're seeing things like security sort of increasing and growing within this market. Again, this is about a 10-year-old market, and database maturity actually takes a little bit of time. But we're seeing more sophisticated security enter into many of these databases. We're also seeing more and capable querying. SQL's been a mainstay of relational, and you can do some SQL querying on NoSQL, but generally it might have more specialized querying language. But we're seeing sort of a blending there, and we're seeing advances in sort of querying technology. We're also seeing manageability, the idea that NoSQL has generally been very favorable to manage the database, and that's becoming even more so, such that administrative time tends to drop on a lot of these databases. And then the last 2 here that are sort of lumped together, one is consistency. This is a particular area I'll go into more detail, but we're seeing database vendors add consistency, which is really sort of broadening NoSQL capabilities in sort of interesting ways. And we're also seeing analytics sort of make their way into this space as well, and we'll talk more about that. So let me go into, I'm not going to cover all these, I'm going to cover these last 2. So let me, for this, let me just talk a little bit about consistency and transactions in general. And so for those that may have had experience in sort of the relational world, this idea of ACID, which is an acronym for atomicity, consistency, isolation, and durability, that's really what that stands for. And really what that means is that in a transaction, the transaction must complete, all components of that transaction must complete for it to be successful. And so what does that really mean? Well, what that might mean in sort of a practical example is if you wanted to withdraw money from your bank, let's say, $100 from your checking account, for instance, if both parties have to sort of be satisfied when that transaction's done. So let's suppose the bank deleted or debited $100 from your account but did not give you the money. You would probably not be very excited about that. Conversely, if you if you withdrew $100, say from an ATM, but it did not necessarily be reflected in your account, you would actually be happy about that, but the bank would not be happy about that. So from an asset standpoint and from databases, all points of that transaction need to complete for all the parties to be excited. Okay, and so this is why when you book a plane ticket, you don't want to find out later that someone else already booked it, or when you bought a product, it's actually not in inventory, and they won't be able to send it to you. So this is what ACID provides. We have sort of expected it within particularly our financial situations. But the idea this is now making its way to NoSQL is pretty significant in the sense that you can have all of the benefits of NoSQL, things like performance and availability, as well as having ACID consistency, really broadens the NoSQL's capabilities. And some of the use cases I've listed here are, have to do with sort of financial trading, banking, as I just mentioned, or telecommunications 360, payment processing, health records, and even when you might want to purchase something, right? All these things play into where you expect and want acidity, or you expect consistency in that data as you're doing that. So let me talk a little bit about this, another sort of trend and thing we're seeing. And this is the idea of, I think I mentioned analytics sort of making their way into NoSQL, and even more particularly making their way being paired with transactions. So in some ways, NoSQL databases have actually been very good at doing operational transactions. Many of them do that. But the idea now that you can have ACID in there, and then we can also apply some analytics as part of that transaction is actually interesting. And it's an area that we call sort of hybrid operational analytic processing. And at 451, we've sort of come up with this term called HOPE, which is called HOPE workloads. It means that they are a transaction as well as an analytical workload occurring at the same time. Traditionally, these have been sort of different workloads, and there's good reasons for that. And there may still be good reasons for that if there's certain systems that want to keep those separate. But generally, analytics tend to be sort of compute intensive, and the idea was that we didn't want bleed over from that compute to interact or to disrupt a transaction. And that's traditionally sort of why they've separated it. But vendors actually gotten very good at sort of, putting those in their certain lanes and be able to carry these out. A term I've heard sometimes before is you can carry a transaction and do some math on it while you're doing that. And sometimes we call this a transaction window. Is that a transaction is generally sort of a little moment in time when some things are occurring, and then it sort of closes up. And the idea is that you have some immediacy in there when an analytic can be turned to either recommend a product to somebody or to suggest something during that little window, or to carry out an action. And that's sometimes what we call the transaction window. Okay. So how does this sort of play out sort of in a more sort of practical nature? Well, the idea is that we have roughly, systems of engagements. We have phone, laptops, and things, and we interact with sort of systems of records, a database at the end, okay? We might do a product search of some sort, and then, sitting off of our system of record is, we see some gears there, maybe some ETL, and this is where then leads to sort of maybe a data warehouse or something like that, where some analysis, some report BI, and other things are sort of going on the business, and that's sort of traditionally how it's been. The new is that we have better and newer systems of engagements before, where it was just sort of people. Now we have devices and tablets and things, and we can interact with systems in a much more sort of fluid way. But so how does this relate to sort of the NoSQL space? Well, NoSQL databases can be systems of record, actually, and this is where sort of that scale comes into place I mentioned, is particularly if you have sort of applications, mobile applications or web-based applications that sort of have high load and different things that actually work very well for NoSQL. And this is sort of where they might play, sort of see on this orange box here. But where is this space sort of going forward? The idea is that we're seeing, and we didn't talk about this as much earlier, but we're seeing more sophisticated analysis and analytics sort of come into the equation. If you notice, the systems of intelligence is up there. And this can also play in a couple ways. This is where we're seeing more sophisticated systems of engagements where you might interact with, sort of a chat bot on something that might determine your need, and then it might go to someone else. But there's some initial intelligence sort of loaded up there in front. And this also can be the idea where, analytics can occur, or certain type of analytics can occur, even driven by machine learning, for instance, on that front end. But the idea is that we're becoming more sophisticated in both our engagement and the way in which we interact with clients and others that might working with our systems. And these are all driven by databases that can handle these front-end loads, and then the ability to do sort of sophisticated analysis on the other side. Okay, so what are some key takeaways? The idea is that, as I mentioned, is that NoSQL has generally it emerged because it was fulfilling a gap in the market. It was fulfilling things that were deficiency, and that's simply why sort of this sector sort of took off. And organizations wanted things like, lower cost, scalability, and availability. They wanted these as part of their systems because as they were growing and maturing, they were finding that one database wasn't necessarily working for everything that they needed. And then the other point here is that NoSQL continues to expand, and we will see not only its growth from a revenue standpoint, but we'll see its maturity and its ability to sort of adopt and take on different scenarios and sort of be applied in much broader areas in the enterprise, and particularly within sort of transformation initiatives that are sort of going on. So with that, I want to thank you for spending your time with us today. Here's some of my contact information if you want to reach out to me. But with that, I want to thank you, and I will turn it over to Ananth to pick up his end. So thank you. Take it away.
All right. Thank you, Jim. You made some brilliant points there, Jim, on specifically how digital transformation is changing the role of NoSQL database, or possibly pushing them up to become a lot more accepted. So what I'm going to do here is provide a perspective from HCL's viewpoint. HCL, of course, is in the business of providing IT services, so I want to provide a view from what we see in the market as we do digital transformation. Quickly, a word on what HCL does as a business, hoping able to forward this. There we go. Okay, a little bit goofy on it. HCL actually is a leader in IT services business, but we've been popular mostly for our engineering heritage. And primarily what we are seeing in the market as we provide these IT services as a global company is digital transformation is truly bringing to the fore a few of the capabilities that are becoming important. From our perspective, this includes building digital platforms, analytics, and obviously these capabilities are today getting interspersed with what intelligence we can get from machines. And all of these capabilities are getting delivered on the cloud. And obviously that brings to bear the question of cybersecurity, right? So from our parlance, truly providing a digital transformation requires the orchestration of these capabilities. And that's where we are focused on as a organization. Right? However, providing these capabilities in a digital transformation requires us to think about what's important in the market. In fact, we did a recent survey with Vance & Bourne, and when we posed these questions to the top CIOs, what came across is most organizations today have a very solid digital transformation strategy, but hardly anybody transcends from going from having a strategy to being able to execute a digital transformation. And that's where we truly come in. And what we've seen as a perspective is as people think about what's truly digital, our viewpoint has been that digital is focusing on providing a customer experience that sets a organization apart from the competition using some sort of a digital technology. So from that viewpoint, our goal has been to focus more on transforming the customer experience. But in order to transform a customer experience, we need the right digital platforms to be able to do that. And unless we're able to measure and derive insights on how we are doing this well, we don't really transform the customer experience. So from our perspective, It's the trifecta of providing the right customer experience, having the right platforms to support their experience, and having the right insights to improve upon those experiences. These aspects are becoming what's core to doing digital transformation. Okay? And this thought process now is being propelled, and a NoSQL kind of technology is becoming pivotal in how we provide this digital transformation. And the best way to understand it is to look at it from these three lenses, right? So when we look at, what's the right customer experience we expect as consumers in today's digital world, the experience is significantly high-touch. As an example, if you are trying to look at, like, say, a financial statement, back in the day, maybe you checked it possibly once a month, or your financial advisor told you what's happening with your investments. Today, we are always on. We want to check it possibly 10 times a day. So customer experience has now become an always-on experience. The ability for you to interact with your customer is pretty much every second. Now, in such a crowd, in such an experience market, the way companies are looking to differentiate is for them to say, how can I contextualize the experience? How can I make it more personalized? What that means is you really need to figure out what's the right experience quickly, which talks about the throughput, and you must be able to get that from a large viewpoint, all right, which makes it personal for you. So NoSQL databases are becoming very important just from the scale and the throughput to provide better experience. In order to provide these experiences, people are thinking modular platforms because the pace of change is increased, which means now data ownerships actually become quite distributed. So traditional relational thought process where you say, hey, I have well-defined schema, I know exactly who owns what, and there are relationships, is disappearing. And data ownerships are becoming bounded in the context in which you're trying to provide an experience. That is changing the market, and NoSQL provides some answers there. And finally, the decisions you take in order to provide these experiences are becoming a lot more. There are micro inferences you want to derive. As an example, if I am trying to buy something based on how I am looking at information, can you derive some micro inference that makes me buy more? People are exploring that, which means decisions are becoming faster. The scope is reducing, but the way in which you make decisions is expanding. So it's not as well defined as it used to be in the past. So the answer is quick, and that's changing the way NoSQL technologies are becoming core to how digital transformation is being delivered. These trends effectively will make technologies, just like you just mentioned, very popular in how digital transformation is being delivered. And I think if I'm able to distill those down into technology trends or architectural mechanisms in which these technologies are being used, I think I can distill down into three. The first one being NoSQL technologies are now becoming a mechanism to increase performance as a persistent and high-performance cache. In the past, caches were primarily used to reduce the latency of what we're trying to deliver, but today that actually transcends to more use cases that we couldn't imagine in the past. Right? It's best explained using a few examples, so I'm going to touch upon that. As an example, if we are in any of the businesses that are into retail or consider food industry or fast food technology, we're seeing the ability where people are saying they need orders, they need integration with technologies such as Uber Eats, and the fact that I'm able to figure out where my location is at any given point in time and what I can link you with up instantly requires a sort of scale that was previously unimagined. And these capabilities are now being pushed to the edge. So the cache implementations we would do are now becoming more persistent and more contextual. We are seeing NoSQL playing a big role there. Another example could be what we're doing for a large bank. If you're on the phone talking to a customer service agent, especially when we look at specialized banks, this is an example where we only serve military personnel. These are people that are out in the field. They're actually putting their life in danger. So the customer service becomes most important to banks like these. So having information on life events that occur, for me to say if somebody's on the phone, hey, I know you recently got deployed to Iraq. I know maybe you're calling because your child is 16, you want to buy a car. The ability to have intelligent conversations becomes important. So the cache that brings up information on people now needs to get smarter. And technologies that we just spoke as NoSQL become important because these caches are getting smarter, their scale is increasing, and the ability for people to have a personalized experience, the window is shrinking. So that becomes a important aspect in which these technologies are being used today. Another possible use case that we see quite popularly is where NoSQL databases are being used as a event or data store specifically in high performance systems. And these systems are becoming more choreographed than they were in the past. As an example, as we build newer technology today, we don't want to decide upfront how various capabilities in a system will interact with each other. We want it to be choreographed. As an example, there is a regulation that the government has been trying hard to implement called PTC, or Positive Train Control. Effectively, what that means is if by any means an engineer on a train is incapacitated or is actually operating the locomotive at a speed or at a mechanism that isn't safe, then there must be a mechanism for us to control the train and take over control without having to leave it at the hands of the engineer. Recent incidents we have had in Seattle or the one we had in Pennsylvania are examples, and this regulation is being pushed. And as systems want to become smarter in the way they manage how they are operated, we now bring in a lot of capability from machines, which quietly is increasing the pace at which information is coming in and at the pace at which decision needs to be made. And obviously, the information that's coming in isn't always in the same consistent format, if you wish, right? So technologies such as NoSQL databases that provides a element of flexibility in the schema and the ability for us to bring in higher throughput are becoming very important in these scenarios. Another example I can think of is if you imagine how we're building shipping systems today for the likes of parcel carriers, think Amazon, think FedEx, think UPS. What's happening is there are millions of events that actually impact how a delivery occurs, right? At any given point in time, I need to be able to promise you a delivery date on an e-commerce site the day you place an order. If I promise you a delivery date, then I need to make sure that my supply chain works to meet the delivery date. As an example, I might have picked up packages that don't fit into one airplane. So obviously, the route planning I've done today will significantly change, which means I am unable to build systems that are well orchestrated in a sequence of steps. Instead, I need to be able to build systems that can change based on events that occur. And in technologies like these, what becomes important is information has to be consistent, which means whatever I put into a system here and I look up a status, it must be the same. It must be geographically distributed because obviously now I'm shipping packages across the world. And more importantly, there has to be selective replication. All these capabilities are something traditional databases wouldn't allow, that the NoSQL databases are catching up to, and they're allowing us to build more event-driven system as opposed to orchestrated systems. Okay? And we are just extending this beyond the realm of applications into security. As a good example, for a large home improvement provider, we are building the ability to have a software-defined perimeter, in which case you don't now decide who has access to system based on firewalls and security policies that sit up front, but you have the ability to manage the entire security perimeter as software, which means the policies are different, the policies are unique. Key value pair kind of technology works best because you need to interpret policies on the fly. So the kind of systems we are building today would require capabilities that are being introduced in NoSQL databases that we see in the market. And finally, to your point, Jim, also about having analytics as a area that's being ripe for using technologies that NoSQLs offer. One of the things we are seeing is we're seeing the ability for us to use NoSQL databases as a mechanism to create a unified data layer on top of legacy assets. What this allows us to do is a variety of things. First of which is, if there are people who have large investments on legacy, we are now able to pull just enough information out to provide an experience that doesn't have to match with the legacy. As an example, all of us invest in 401k, and today most 401k providers in the market run on mainframes. However, it's going to take significant amount of energy for them to move away and very little benefit, because 401k is a low margin business for people to move away from it. And where technologies such as NoSQL come into play is we are able to create a unified customer access layer, and we are able to provide new capabilities on top of it, such as robo-advisory for investments, so that we can continue to provide better advisory capabilities, whereas the core record keeping for 401k can continue to remain on mainframes. So that has been an interesting use of technologies such as these. But going back to what 451 called as hope, we're also seeing significant growth in transaction systems that are also being used for analytics. A great example of that is pharma research. Today we are working with pharma companies to reduce the cost it takes in actually bringing down the cost of research. As an example, as research happens, people are making specific observations on how a chemical worked against a tissue. And we do millions of such experiments before somebody says, hey, you know what, this drug can solve a problem. And the ability for somebody to identify a transaction and say, hey, if these transactions followed a specific sequence, then I had another transaction that followed the same sequence and ended up in a failure of a test. Would you consider recalibrating, or do you really want to continue with such a research? We'll actually save billions of dollars from how much people are spending on research. And today's NoSQL technology allows us to do that. As we create transactions, our ability to go look for a specific pattern in transactions across thousands of research samples we've done in the past, and the ability for us to say, hey, is this the right thing you're doing, or would you want to move away, is a great example of where we're using it. And finally, the most exciting use case that I have implemented would be in flight test, which is, if you think of airplanes and how data is being used, it takes about a year to certify an airplane as safe to fly by the FAA. That's because we do hundreds and thousands of hours of wind tunnel tests, an equal amount of thousands of hours of actual flying tests before an airplane is safe. And technologies such as fluid dynamics are able to cut this down by writing algorithms that say, hey, if I can mathematically prove that a specific object in space acts a specific way, would you then consider reducing the number of wind tunnel tests? The challenge we have had today is, how do you express a complex piece of information that's easily retrievable in a relational database? That has been always a gripe. So people have invented new ways of doing Unix file systems to be able to read files. And what we are able to do today, thanks to current NoSQL technology, because of the volume of data and the space at which we can query it, is we are able to put all of this information in and then say, hey, if I'm making a specific test with a specific accuracy ratio, would you go and find everything that has happened with a similar airplane across military and civilian aircrafts in the past? And we're able to match the data and say, at some point in time by 2022, we hope that we'll be able to actually certify a flight as safe purely by science without having to go through any wind tunnel tests. So the scope, in summary, for NoSQL databases is massive, and we're seeing this across a variety of implementation use cases, be it as a cache, be it as a solid high-performance event and data store, or be it as a mechanism to create analytics or new experience over existing data sources. But I think the promise is significant. With that, I think that's a good summary of what we are seeing in the market. I'll turn it back to Matt for him to take questions.
Okay, great. Thanks, Ananth. Yeah, really, really insightful presentations each. So with that, we've got a few questions to cover. I think the first one I'll direct towards Jim and say, Jim, enterprises employ many databases for many reasons. And on the one side, you had with new systems of intelligence, you show systems of engagement, systems of record, systems of analysis, and systems of intelligence. Could you reiterate what databases you see that tend to play in each area? And if at all possible, do you see databases spanning multiple platforms there?
Yeah, that's actually a good question, Matt. Yeah, I think I was hoping that from the slide, well, it can do one of two things. That slide was more, it was showing sort of logical functional areas. There are in each of those areas, say, sort of systems of engagement. That can be a phone, laptop, or something in which someone engages another system, digitally or electronically. Below that, I think, with systems of record. And within that space, you could, I think I mentioned NoSQL generally plays or can play in that space most often. You might also see a relational database in there as well, okay? And then, there's also, this hope thing I talked about. There's databases that sort of do both of those. And I guess maybe even those could even be in there to some extent. On the other side, going to the right where sort of the analysis was happening, that's oftentimes sort of data warehouses and the various iterations of that. Basically it's offloading information or receiving information from sort of a system of record and enabling sort of analysis to be done. They can be separate systems, Matt, to your point, but it's entirely possible that depending on the need and the use case, it could be one system. Okay. Like I said, it depends on what the use case is, but particularly on sort of the systems of engagement, system of record, that can often be sort of a singular NoSQL instance sort of functioning there as well, and then maybe that might function, say, with the data warehouse. So it does matter, Matt, but I'm generally seeing that at least generally most will have a couple of different databases in there, but they do try to consolidate most definitely when they can. So. Okay,
great. Next question is for Ananth. Ananth, how does the NoSQL data consolidation layer update mainframe at the end of the day? Does it also serve as the intraday system of record, and does it offload mainframe cycles?
That's an interesting question, Matt. What we have seen from our experience is a layer of consolidation, as we showed, most times works to provide a better experience to how people are using the system. Most times it does act as a intraday system, which means it can collect information along the day, but we will retain mainframes as a system of record. So it can then write back to the mainframe at the end of the day. In some other scenarios, the transactions flow back to the mainframe, and the mainframe will push the transaction back to the NoSQL layer for it to continue working. In most of these cases, take this example, right? So let's say, going back to the 401k example, if I built an advisory platform on the mainframe and then you logged in 10 times a day to see how your funds were doing, that just increases MIPS significantly. So this layer does offer benefit in terms of reducing how much people do spend on the mainframe without having to rip the whole thing apart and then build a new system. So it provides a nice balance of providing the right experience and taking cost out of the mainframe.
Yeah, so very flexible. Okay, thank you. Next question is for Jim. Jim, can you describe the value of the quote-unquote transaction window? So if it were to take, say, an extra half second of time longer to execute something online, what might be the penalty, or what's the overall value of the transaction window that enterprises that you see are trying to leverage?
Yeah, I actually get questions on this frequently, but the idea of a transaction window is, a transaction is essentially sort of a moment in time when, I think I mentioned, you might withdraw money from your bank or something like that, and then it sort of ends. It kind of has a fixed kind of start and a fixed kind of stop. You're not necessarily going to be, pulling out money all day from your account, right? So it's sort of a little scenario, and within that scenario, you want to, perhaps carry out some. I think Ananth, pointed out, sort of having a list of sort of pattern detection and then sort of carrying that off. So if it matches that pattern, it can sort of take that action. And the idea is that once that transaction closes, if you haven't nor sort of taken action within that, you sort of lose the moment. You sort of lose that opportunity. And when you're talking fraud, it could mean you may have taken a loss. You may have missed that one, or you may have caught someone. So there is potentially particular risk involved if you sort of miss that transaction window. Or you may miss a sale. If someone's buying something and you may want to recommend or suggest something in a certain way, if they're not sort of in the moment of that transaction, you sort of miss that. So it could actually be a pretty big penalty depending on, like if money is involved or something. So.
Sure. No, it makes a lot of sense. Ananth, you listed a lot of use cases for NoSQL. Could you comment about how NoSQL, or at least strong consistency, might play into logistics and shipping? It wasn't clear to the audience necessarily.
Okay. In that specific example with the man, consider shipping as an example. If somebody said a specific package is on an airplane, then we have to be certain that the specific shipment is on an airplane. Unless the consistency exists, we don't want, specifically with choreographed systems, if systems do not see the same status, they may actually take another action that was not intended. So strong consistency will be building choreographed systems, especially if they're going against the same grid, is very important, specifically to ensure that we don't create duplicates of action.
Mm-hmm. Okay. Jim, you're talking about NoSQL databases. Could you comment on similarly, the added capabilities of strong consistency and analytics? So, can you comment on use cases that NoSQL databases are able to pursue? Let me rephrase that. So now that you're seeing strong consistency and analytics, what are NoSQL databases now able to do? Are they encroaching on relational systems, or is this just new functionality you're seeing in the market with strong consistency and analytics for NoSQL?
Yeah, I see it, and that's an interesting sort of take on that. I see it as a couple of ways. I see it that, so if you sort of step back from it, relational databases often have sort of defined themselves by providing that. And if an enterprise sort of needs ACID, that would be their first choice. And sometimes they would give up certain things, even performance, for instance, if to have ACID, because it when in terms of money and health and things like that, like it sort of matters, right? You want to get it right. Otherwise, it can cause headaches for you. I think, as Ananth said, we don't want to have duplicates and stuff. So the idea that ACID now is making its way to NoSQL, enabling that, I think there's a couple of things. I think it often opens up, hey, we were already running sort of a system of record and transaction with our NoSQL. Now we can sort of broaden or expand that or add additional functionality. So I think it's picking up sort of new areas. I think it's also picking up transactional areas where maybe a certain application wasn't a good fit, and we see this all the time with the relational. and now that that's available, strong consistency, it can move over to that workload. And not only can it move over to the workload, it can maintain some of the same things that NoSQL has. Performance, scalability, I think it's additive, I think, as I mentioned. But that also means that there might also be a cost improvement there of now I'm being more efficient with my workloads. I'm running them on systems that might have better sort of ROI associated with them. But just in terms of that, I think like I mentioned, I think to trading scenarios or something, if you're trading stocks or something like that, sort of look up in price, which is sort of a fast query and a fast write. I think NoSQL actually is probably a good spot for that. Recommendations I think are good. Although it may not necessarily require ACID. Purchasing, something like that. You want to get the product, want to get it right, and no one else wants to buy that. So these are scenarios, but I think it will start to peel away some ACID transactions that have normally done on relational. I think they'll make their way to NoSQL.
Sure. No, that makes sense. Okay. I think this final question will be for Ananth. So we've talked a little bit, Ananth, about some of the trends. Obviously, NoSQL, what Jim just mentioned with strong consistency in analytics. Something else that we see in the marketplace, I would imagine that you see a lot in your line of work, are microservices. Could you comment a little bit on how NoSQL may or may not be a good fit with microservices architectures?
Okay. Sure, Matt. One of the patterns we did discuss in the webinar was where we see NoSQL databases becoming data or event stores for high-performance architectures. Thanks to microservices, as we want to build systems that are more easy to change, like I said, as pace of change increases, we want to build more modular architectures. As we become more modular, the ownership of data itself is getting distributed, so sharding becomes an important aspect. And the responsibility of having a strong schema, or that would be previously the responsibility of relational databases, now move to services from the databases. So while we can achieve scale at the services layer, having data structures be large and bulky and common, like we used to in the past, will just move the limitation of scale down to the database layer. So we're seeing significant change in how people are looking at data, specifically how people are building schemas, and that's an important consideration. And NoSQL databases from that perspective are really becoming very popular in a microservices architecture.
It almost sounds like it really facilitates a DevOps environment as well.
It does, right? So pace of change dictates it, yes. Okay,
great. Well, I just want to thank both Ananth and Jim for participating and presenting on today's webinar. I want to thank everyone for joining us today. We will make these slides again available, as well as a replay of this for if you want to listen in again or share it with additional colleagues. So with that, I want to thank you, and everyone have a good day.
Thank you.
Thank you.